Here is example 3 from 2.7 day 1. This will definitely be the most involved example that we've had so far. And also at the end, I'm going to show you an alternate way to check your solutions, because one of the solutions we're going to find doesn't work, and we'll see that here in a little bit. But step 1 is actually going to be very important in this case. The step 1 for solving these equations is to factor anything that has, it's not factored completely. So x squared minus x minus 2. If we're to factor this one, that factors as x plus 1 and x minus 2. That's going to be kind of important here, because when you're trying to find the LCD, if we know that it's x plus 1, x minus 2, well, we've got those two same things here, and we don't have to have as large of an LCD in this case. If you make the mistake of not factoring this, and you do x plus 1 times x minus 2 times x squared minus x minus 2, all of that huge stuff in the LCD, what you'll find if that's what you do is that this problem will blow up. It'll take a lot longer than you would have hoped for. So that's why that first step is really important. It saves you a lot of time in the long run. But let's go from there then as our least common denominator. Like before, we're going to multiply everything by that least common denominator. So x plus 1, x minus 2. The whole point here is to get rid of fractions, and so now we multiply by this one. The x minus 1 is going to drop out. We're going to be left with the x minus 2, and the 3x also sticks around. So we have 3x times x minus 2. Then on this next one, the x minus 2 drops out, and so we have 5 times x plus 1 left over. And then the nice thing about the right-hand side is that all of this is canceled with all of this. That's kind of the point. And so then that side is equal to just 15, and so we can move forward from there. As before, once we get it to this point with no fractions, we are going to use some of our normal equation solving strategies. Let's first of all distribute and combine like terms. So that'll be 3x squared minus 6x. And then we have plus 5x and plus 5 equal to 15. All right, then we combine like terms. We can put those together. 3x squared minus x plus 5 equals 15. And then because we're solving a quadratic, let's subtract the 15, put it over on the left-hand side so that we have everything in standard form. So we get it to this form. Now, the next step here, if you can, is to factor, and this one actually can be factored, so that's a good thing. We'll factor this one. You might want to pause the video right now and try this on your own to see if you've got the factoring down. But as far as how we get to this factoring, the way we'll start off with, the 3x squared can be split up as 3x and x. Now, I'm aware that a lot of you have strategies for factoring that you may have learned from another class, some sort of trick with greatest common factor or something like that. But I'm just going to show you the guess and check method for solving this again. Now, obviously, I know what the answer is already, so I'm not going to do all the guess and check. But what you have to make sure you do is when you have your guess in here, I'm gonna put in plus 5 minus 2. Remember that the 5 and the negative 2 need to multiply to negative 10. The negative x part in the middle, that's when we take these two multiplied plus these two multiplied. That's going to help us get what's in the middle here. So this is 5x, and then 3x times negative 2 is negative 6x. So you combine those together, and it does in fact combine to negative x. And so that way we know we have the correct factoring in this case. Now once we have the factoring, we get our solutions. And so our solutions are going to be whatever makes each factor 0. In this case, it's 2. And then in this case, minus the 5 divided by 3. If you want to set up a mini equation, you can, but that ends up being negative 5/3. Now, we have a couple of solutions, and they look like they're both solutions to our equation here, but we have to check this to make sure. We're going to plug these numbers in down here and just see if there's anything that doesn't work. Now, one that pops out right away is this 2 goes into x minus 2, and it makes that denominator 0. It's also going to make this denominator 0. So we know that this one is undefined. So that is just going to be gone as a solution. I want you to, when you're solving these, just put an x through it. Don't erase it, because if you put an x through it, means I found it. I found that it wasn't going to work, and so now it's gone. But the 5/3, so that one's really nasty as far as plugging it all in, but I can tell you, you can take my word for it, that it actually does work. So that's one way to check it. That's checking it numerically by just plugging them in. Another way to check your work is if you use the graph. So one last thing I'll mention, then this one will be done, is how we can check with the graph. So here's our original equation. If you were to just put all of this on one side, like you see down here, and put this into your y1, you could graph that or put it on Desmos or whatever it might be, and you look at this and say, all right, where is it equal to 0? The features on this graph looks like the only place it crosses is right here. Now, that's certainly not positive 2, and we don't see a positive 2 over there, so it kind of makes sense that that positive 2 wasn't there in our algebraic check. But then this one right here looks like it's somewhere between -1 and -2, so negative 5/3 seems to be a pretty reasonable estimate for that point right there. So that just is a different way to check. You can use that way, you can use the algebraic way. I'm not worried about you showing how you checked it, but just make sure you know which answers are, in fact, the correct ones.